Hi friends, a warm welcome to you all back to the day 2 session of pharmaceutical analytics. Yesterday we have been discussing about the applications of pharmaceutical analytics. We have discussed about many applications of it till yesterday. We know what is pharmaceutical analysis and what it means and what are the different applications we have based on the pharmaceutical analysis. Right. Drug classification. Generally, it means a drug classification. Now, how the drug and how it will save the people's life. It depends. We need to look into the drugs, how it is safety for the patient. There are some industrial standards were maintained to look into that. So we have encountered a lot of things regarding the pharmaceutical analytics. In today's session, we will see about the CRISP-MLQ methodology. CRISP-MLQ methodology. I already said we have discussed yesterday regarding it. It is called as cross-industrial standard for machine learning with a quality assurance. We have discussed these things yesterday. Today we will discuss this CRISP-MLQ methodology in a detailed manner so that we will have an idea about it. So before getting into the CRISP-MLQ methodology, we will just have a look at the pharmaceutical analysis and where it's really applied and how it is very useful for us and all these things. We have discussed yesterday about qualitative, quantitative, and semi-quantitative analysis. All these comes under the pharmaceutical analysis. I don't think we want to discuss about it since we have discussed a lot about the things yesterday. Today, let's see the agenda for the day. We have stages of analytics. Yeah, stages of analytics. There are 4 stages of analytics. Four stages of analytics. That comes under, this is some short form of it. So before understanding about the, if you're going to any data analysis or any analysis, you need to do all these 4 analysis step by step. What is it called as? The 4 analytics is called as DDVP. What is this DDVP? First D stands for descriptive analytics. Descriptive analysis. The second D stands for diagnostic analysis. Diagnostic analysis. The first P represent predictive analysis. Predictive analysis. Sorry, analysis. Then the last P represents prescriptive analysis. Prescriptive analysis. These are the 4 different analysis we have. So first we will start with descriptive, end with prescriptive analytics. So at the third stage, we will do predictive analysis before we will do diagnostic analysis. And there are some stages of analysis are there, right? Then, as I stated here, CRISP-MLQ methodology stands for cross industrial standard process. Cross industrial standard process for machine learning with quality assurance. With a quality assurance. We will look into, there are some stages in this. We will look into that one by one once we proceed into the session. Then there is something called inferential statistics. Inferential statistics, what it means. So by the meaning, I can say there is, I'm going to get some inferences. Okay. The meaning I can say I'm going to get some inferences. Some statistics is also going to be included. What is the statistics and what is the inference we are going to get out of it? That is the thing here. All right. Then we will jump into supervised and unsupervised learnings. What is unsupervised and what is supervised? So if we know about supervised, then other thing is called as unsupervised, right? So we will look into what is supervised and what is unsupervised learning. Then we have data split. Then we have evaluation method is also called as error functions. That is evaluation methods. Evaluations methods. Fine. We have overfitting, underfitting. You want to know what is overfitting, what is underfitting? You look into it. So we'll learn what is overfitting and what is underfitting and how to resolve that overfitting and underfitting. We'll also look into those kind of things. So this is the agenda for the day. We will encounter all these things in today's session itself. Okay. Now we will start with the slides. First thing we have to know about is stages of analytics. As I stated, the stages of analytics starts from descriptive analytics. Descriptive analytics. What is this descriptive analytics? Analytics speaks about what happened in the past. What happened in the past. What happened in the past. What descriptive analytics speaks about. Descriptive analysis speaks about what happened in the past. Second thing we have is diagnostic analysis. First, we will take a problem and we will try to understand what is the stages of analysis. Let us take COVID cases. Okay, COVID cases. Let us take COVID cases. So when we take the COVID cases, in 2019, maybe let's aim for 2020. In 2020, okay, in 2020, I'm started to analyze COVID-19 cases. So I'm looking back at 2019, what happened in the past. And this is my x-axis and this is my y-axis. And this is years we can say, okay, this is years and that it may be month we can say, this is years, let us assume it, okay. No, this is not years, this is COVID cases. Number of COVID cases. So first, for the first month, second month, third month, fourth month, fifth month, sixth month, let us take 6 months of data. I can see that on the first month, the case is this much. Second month, the case is this much. Third month, the case is this much. Fourth month, the case is this much. Fifth month, the case is this much. And sixth month, the case is this much. Okay. So my analysis says that what happened in the past is this is what happened. This is what we will do in descriptive analysis. We will look into what happened in the past. Now that is fine. I have done that, what happened in the past. Now, okay, now the point came here. That is why it happened. Why it happened. That speaks about descriptive analytics. That speaks about descriptive analytics. Why it happened. So I'm going and looking at it. Why this particular period, that is at the fourth month, it was high. Why it is high? Let us assume I found a reason. I found a reason. And why it dropped? I also found a reason. Found. So I found a reason why it happened and why this also happened. So why is completed now? The second part of analysis is completed. We have the third analytics, which is predictive analytics. Where it will predict, okay, where it will predict why it will predict the future. Let us say I analyze this and I come to know because of any reason, because of some reason, okay, because of some reason, I come to know that we know that because of some reason here it is dropped. Here it is dropped. So with the help of this or with the help of the data, I come to know that I predicted that on the next year, that is now we are at 2020. We looked into 2019 data and analyzed what has happened till present and why is happened. Now I am saying that in 2021, the number of COVID cases, the number of COVID cases, will reduce, by some percentage. I'm saying 30%. So what is likely to happen? What is likely to happen? This speaks about the predictive analysis. So I hope it is clear for you till the predictive analysis. We have something called prescriptive analytics. We have something called prescriptive analytics. Okay, where the prescriptive analysis says, what if analysis. What if analysis? Like let us say that I detected the I predicted that on by 2021 the COVID cases will reduce by 30%. So taking actions based on the prediction, is called as prescriptive analysis. So I want to make my prediction to be true. So what are the steps I have to take for that? I have to take some steps in order to fulfill my predictive analysis. So what are the steps I'm going to take? Let me say that I can make a lot of campaigns, or I can make some of the I can make of dosages. I will go home by home and I give the insulin, the dosages, all these things I can give to them so that it will reduce. So DDPP, descriptive, at the end we have prescriptive, diagnostic we have predictive. Okay, so we will describe what happened in past and why happened is diagnostic. I will diagnose what has happened and I will predict what is going to happen, and I will take the required measures to fulfill my prediction. So this is what stages of analytics will do. Right? I hope this stages of analytics is clear for you. So I don't want to make it much. So this is enough for the stages of analytics. Fine. Now we will have. So I hope that this is clear, right? The stages of analytics is clear. Now we will discuss about the CRISP-MLQ standards. So here we know that CRISP-MLQ stands for Cross Industrial Standard Process for Machine Learning with Quality Assurance. Cross Industrial Standard Process for Machine Learning with the quality assurance. We have some 6 phases in it, right? Phase 1, business understanding and data understanding. Let us discuss this business and data understanding in detail. So now let us speak about business understanding. What is business understanding? So we have a business problem. Let us assume we have a business problem. Okay. Let us assume that we have a business problem. The business problem, what we have here, let us say we'll take some example here. We'll take some other examples. So let us say I want to know the significant proportion of customers who take drugs and unable to pay the money, or significant proportion of customers who take insurance, medical insurance, and unable to pay the loan amount. Okay, that is default. Now, first thing we have to do in business understanding is we need to look into what is the business problem. So my business problem is significant proportion of customers who take insurance and unable to pay the insurance amount, medical insurance, and they are not able to pay the amount. Now, I want to say the first thing is, what is the business objective? What is the business objective? The first thing we have to look into. What is the business objective? Business objective is the business objective. The business objective is to minimize the insurance defaulters. Insurance who will not pay the insurance and they will go like that. Insurance defaulters, or in banking domain, we can say loan defaulters. We'll take banking domain, loan defaulters. So I have to minimize my person who are getting the loan, that who are running with the loan amount. I want to reduce those kind of person. The first thing we have to think about the business objective. Defaulter means the person who is not paying the amount, Non-defaulter means who is paying the amount. Okay, so that is we are defaulter, who is not paying the amount. So I want to minimize that kind of person. So once we define the business objective, First point is to define the business objective. This is very important. Let us say once you understand the business objective, you have to look into business constraint. What is business constraint? So business constraint is simple. Let us say you are reducing the persons who are not paying the loan, running with the amount, that is defaulters, you are reducing them. So by reducing the number of customers, when number of customers is reduced, okay, when number of customers is reduced, what will happen? When the number of customers is reduced, let us say, okay, what will happen? I can't give the loan to anyone, right? So if the number of customers reduce, I'm getting money from the RBI or Reserve Bank of India, which is like I have to pay the debt to them. So without providing the loan to the people, how I'm going to pay the debt to RBI? That is my question here. So here there is a side effect. When I do the business objective, when I give success to my business objective, there is some drawback happening here. So this is some side effects. Let us say some side effects are happening for this business constraints. Some side effects are happening, let us say, okay. So this needs to put as the constraint. This needs to put as the constraint. Clear? So side effects need to put as the constraint. So I can say my constraint is maximize the profit. Now you can come to know that minimize the insurance defaulters, minimize the loan defaulters by maximizing the profit. Now there is no side effect to me. Now I understood the business problem completely. And this is a valid success criteria for the business problem. What is success criteria? Now this is my business problem. As the first step of my understanding, I come to know this is my business problem. Now we have to define the second stage is we have to define the success criteria. Define the success criteria. We have to define the success criteria. How will we define the success criteria? Now, first, what is the business criteria based on the business problem? I say that I should minimize the defaulter by increasing the profit. So there should be some tolerance level that given by the customer, that given by my customer. They say that my loan defaulter, that is the defaulters, those who are picking up my loan and running away, they can be there, but some 2% to 5% of the people can be there. Not much. 2% to 5% of people can be there. My bank says this is my business criteria based on the business problem. Bank says, or insurance says, or medical says. What is the machine learning criteria? machine learning criteria. Accuracy should be greater than some 90% or 95 or 98%, because it is a medical field. If it is a banking domain, I can say some 90% is fine. And also the speed of the algorithm and the results given by it should be in within a second. So 1 second, the algorithm should process it. So accuracy should be high, greater than 90%, and it should be in 1 second. Performance 1 second. Right? So this is my business machine learning criteria, right? So define the success criteria as this, and machine learning criteria is this. So this is the criteria. Fine. Now, there is some economic success criteria. Economic success criteria. So these many things are there to consider a business problem, first of all. So we have to, first thing, we have to know the business objective. Then we have to analyze the constraint, and we need to put a constraint. The second one is we have to define the success criteria, like 2 to 5% it is says by the bank, the defaulters can be. And machine learning accuracy should be greater than 98 in case of medical pharmaceutical industries. And this is loan, so can have some 85 or 90%. Performance should be in 1 second. Now economic criteria, like I'm investing some for this project, I'm investing some 100K US dollars. Okay. For this project, how much I will get in return of invest? How much I will get? Because when it succeeds, what is the profit I'm going to get from it? That is around some 500K. So we have to measure the economic success criteria as well. So this is the wonderful thing, right? When you give this kind of inferences to the client, what the client will say? They can't say anything, right? So business objective, business constraints, then success criteria, machine learning criteria, then economic success criteria. When you provide this kind of inferences in front of the business, this is fine. So we have to define all this business for the business understanding. First point. So what are the things? First one, business objective and constraint. Then success criteria of algorithm, that is machine learning algorithm should be accuracy should be this and performance should be this. And what is the economic success criteria? Some return on investment we can say. What is my return of investment? Return on investment. Right? This speaks about the business understanding. Let us quickly jump into the data understanding now. Sorry, guys. Okay. Data understanding. So now you understood the business problem. Let us say you clearly understand the business problem. Okay. First thing, I clearly understand the business problem. Now, once I understand the business problem, I have to collect the data required. There are two sources of data, primary and secondary source. I will discuss that. Okay. Data are primary, secondary, and we have one more data, that is syndicate data. Syndicate data. So what is primary data? The data which is collected. The data which is collected, okay, by doing some surveys hand on. If you go and get the data, that is called as primary data. Secondary data is readily available data. Readily available data. Syndicate data, you will pay the money to the company and get the data. Will pay the money to the company and get the data. That is syndicate data. Now, so past data which are organizing is capturing past data. So secondary data is any past data is available, or any data is available from the company itself. From the company itself, if any data is available, how it is available. Previously, any project is done for the company. Previously, any project is done for the company. The company will have, okay, the company will have OPA. OPA, that is organizational process asset. Organizational process asset. So organization process asset. The company will have OPA. Now we can get from this asset, the data might be stored. So if you can get a data from that kind of instance, then it's called a secondary data. Right? Then we have syndicate data. Let us say with an example. Let's say we need some data from the company. Let us say if you are getting some agricultural field or project and you want to fly a drone around it, and you have to get the data from the what kind of crops and all these informations. So what you have to do, you have to run the drone around it. Maybe the drone people might have already run and they have the data in their hand. That is the company data they have. So they will ask some money to us. Maybe you have to give some $1,000 or $2,000 or $5,000. Once you give that money to me, then once you give that money to me, then I will provide the data. When that kind of data, if you got, that is called as syndicate data. Syndicate data. Okay. Now we will analyze different types of data. What are the types of data we have? Okay. What are the different types of data that we have in our hand? First of all, you need to understand about data. Data is a piece of information. All piece of information is called as a data. Data is something which can be measured, which can be measured. Data is something which can be measured. Why we have to measure? Because to use for the analysis. So once we measure the data, we can use for the analysis. Why analysis is required? Because once we analyze the data, so first we will measure the data which can be measured, then we will measure the data, then we will use for the analysis. Once analysis is done, it is transferred to the building of model building. Once the model building done, then you can used for prediction. So measures used for analysis, then model building, then it is used for prediction. Then after predicting, we'll use for optimization. Example, the optimization like the constraint is some sale should be some 100K. So having the constraint, we have to maximize the sales, let us say, or maximize the loan profit. Okay. So which will use for an optimization problem. So once the optimization is done, it can be done with the use of, we can send to the management. Then the management will check on the constraints. Right. This is the flow of the data actually. Okay. Okay. This is out of our data. So let us deep dive into the different data types. Different data types. We have continuous data. Okay. And discrete data. Two things. Continuous, discrete. Okay. Continuous data which can be represented in decimal format. Continuous data. Discrete data which cannot be represented in decimal format. Okay. If you can represent a data in decimal form, it is a continuous data. If we cannot represent the data in decimal form, that is discrete data. This discrete data categorical data we have. We have count data. Discrete data cannot be represented in decimal format. Categorical data, obviously we cannot represent it in the decimal format. We have some binary class. We have multi-class. We have binary class. We have multi-class. Okay. Binary class means we have two class, default or not default, customer churn out or not churn out. Then a lot of things are there, live or dead, like that. We have classifications. More than two classification, we call it as a multi-class. More than two, it is called as multi-class classification. There are some examples. on multiple class classifications. So categorical data comes under discrete. We have count data. Count data is like number of times your wife beats you, number of times a customer pass the loan, pays the loan, or number of times the customer churn out of time, customer pays the loan, number of times the customer churn out. So this comes under count data. So the data types are continuous, discrete, okay, continuous, which can be represented in a decimal format, discrete, which cannot be represented in a decimal format, which cannot be represented in decimal format. Obviously, categorical data is textual data. You cannot represent the textual data into a discrete format, right? Then we have a count data. Number of times your wife meets you, number of times your customer, that is not going to be in a decimal format. You cannot say my wife beat me 2.2 times, right? This is about the data types. We have few more interesting about the data types. We have nominal data, we have ordinal data, we have interval data, we have ratio data. Okay, nominal, least preferred data. Why? Only few statistical operation can be done on this data. For example, mode, proportions, frequencies, percentage, like this we can take. Ratio is the most preferred data where all kind of statistical analysis can be done on this data. All statistical analysis can be done. Interval data and ordinal data. Ordinal data is orders: mean, median, mode, median, proportion, frequencies, percentage, rank order, like that. Interval data and ratio data we will discuss in detail now. What is interval and what is ratio? Interval data is subjective. Subjective. If it is subjective, ratios are objective. I will give you example for interval and ratio data. Interval data is subjective, as I stated. Let us take Chennai, Bangalore, Ooty. No, Antarctica. We know that in Antarctica it is in -°C, right? In Bangalore it is somewhat less °C, that is around 20°C, like that. In Chennai it is 48°C, very high heat. Here bit cold, here lot is cold, more cold. Now a person from Bangalore goes to Chennai. What he will say? He will say it is hot. It is hot. The same person goes to Antarctica. What he will say? It is too cold. If a person from Antarctica go to Bangalore, he will say fine, somewhat. If the same person go to Chennai, he will not survive there. He might die. So temperature is subjective. Temperature is subjective. We can say temperature. We can say IQ. We can say that the person may have some good IQ scales, This person might have some less IQ skills. It depends on the subject, right? So this factor comes under subjective. Objective. Ratio subjective. Let us say, same example. There is a bookshop called as, let us assume, there is a bookshop called as famous something. We'll take some good books, famous book, the worldwide book they can take. We will take some Banzal books, Banzal book, Banzal book. Or you can take Theory of Everything. So when I take this book, in Bangalore, the book cost is 500 rupees. In Chennai, same 500 rupees. In Antarctica, 500 rupees. So the amount of the book is not going to change. So this kind of data comes under subjective, that is also objective, that is ratio data. Or else we can say it has some meaningful zero, in it, which ratio data, which have some meaningful zero in it, ratio data. Interval data have no meaningful zero in it, How? I cannot say a person is having zero IQ, because persons will have some amount of IQ in them. Some IQ will be there for the persons. Some temperature will be there. We can't say 0 degrees Celsius is also a Celsius. 0 degree Fahrenheit is also a Fahrenheit. So you cannot say a 0 degree Celsius, 0 degree Fahrenheit like that. That is for sure. Right? Yes. Now, this is fine. Ratio. I have some meaningful zeros. I can say the pen is $0. I have 0 rupees. I can have it. I don't have money. It's called as 0 rupees. So zero meaningful zeros will be there. In interval data, no meaningful zero will be there. Nominal data, train number, bus number, which is not useful. Ordinal, order data. So this is about the types of data. Now, continuous data, which can be represented in the form of decimal point. Is it possible that I can say $50.5 a pencil? Yeah. Then ratio is a continuous data. Is it possible that I have 10.10 degrees Celsius? Yes. Then interval is a continuous data. Is it possible that I can say I have a 5.5 order? No, I can't say it. So it is not a continuous data. Nominal, you can't say. Discrete data, what is it? Cannot be expressed in decimal format. So ordinal is cannot be expressed in decimal format. So it is a discrete data. Nominal is also a discrete data, right? Categorical, we can say. Count data is also a discrete data. So discrete, which cannot be expressed in decimal format. Continuous, which can be expressed in a decimal format. Categorical, sorry, numeric data. Categorical data is discrete data. Right? Now, so we have two higher class, that is qualitative and quantitative. Okay. Qualitative data, how much quality it is, how much quantity it is. Let us say I am very far. When we speak about quantity, I'm saying that I'm 5 kilometers away from the office. That is comes under quantitative number, right? So which can be expressed in a decimal format. So interval, ratio, and count will come under quantitative, and categorical will come under qualitative data. So this is about the types of data. We have structured data, semi-structured data, we have unstructured data. What is structured data? Before this, I will explain this again. So we know that discrete and continuous. Discrete, continuous. Discrete is a categorical. We can say cross it. So categorical. So categorical data cannot be expressed in a decimal format, not possible. So nominal, ordinal, count will come under discrete. Categorical, which can be expressed in a decimal format. So interval, ratio come under this. Most preferred is ratio, least preferred is nominal, because ratio, all type of analysis, statistical analytics can be done. In nominal, we cannot do all types of statistical analysis because of this. Then we have structured data, unstructured data, we have semi-structured data. When structured data is there, structured data, it's in a tabular format. Unstructured data not in a tabular format. Semi-structured data partially can be in the tabular format. So SQL database can have all type of data in it, like structured, it can have, like it will have some structured format data to put the database data into the databases. Unstructured data we can't have. So we have videos, audio, like images, text. This comes under unstructured data. We have semi-structured data, XML, HTML. This all JSON comes under, because it is easy to convert a partial amount of data into a structured format, right? So we can transfer the unstructured data into a structured data using transformation. Unstructured data into a structured data using transformation. Using transformation. Unstructured data into a structured data using the transformation. Now we have big data. Big data. The data which is providing storage burden and the computational burden. Storage burden and computational burden. We can say that as a big data. Volume, velocity, and variety. 3 V's. Volume, velocity, and variety. Volume, velocity, variety. High volume of data coming in. A very high speed data is generated, that is veracity, that is velocity. Variety is like different data sources, let us say videos, audios, images, that is called veracity. When a data is having all this kind of things, 3 V's, then it is called as a, then it is also called, then is a big data, we can say. Okay, so I can save the structured, unstructured, semi-structured data in, like I can handle the small data, that is not a big data, we can handle in some databases where we can store the big data. We can store it in a Hadoop framework. Storage of non-big data. Easy. SQL, no SQL, we can see. So this is about the data understanding, I hope. I hope that business and data understanding is very important. So I explained to you in detail about this too. Now we have data preparation. Once the data is done, okay, once you have done the data completely, that you have prepared the data, you have done it. Okay. We have a lot of things as well, cross-sectional data. So let us speak about it as well. We have cross-sectional data. We have time series data. We have panel or longitudinal data. Cross-sectional data where date and time is unimportant. Time series, time and date is important. Sequence is not important. Sequence is also important. So date and time is not important, so sequence is not important. In panel or longitudinal data, it will have some multiple column properties. Okay, so actually this is enough. We have to think for the data. Balanced data, imbalanced data, you know. Now we have understood about the data, primary, secondaries, and all these things. Now let us get into the data preparation, where we will do some exploratory data analysis, EDA, where this analysis helps us to do, if you have prepared the data into structured format or unstructured format, everything you know that. If you have unstructured format data, you can convert it to a structured format data by using transformation. I hope you have done that as well. You have clear idea about it. Data preparation is like your data might have outliers. Your data might have a lot of wrong informations. Let us assume that maybe outliers can be there, maybe what we call it as missing values can be there, type may be different. So all these corrections should be made in the data pre-processing steps. Then we have model building and tuning. We have to build the model. We have to build the model. How to build a model and how to tune it. Model building and tuning. Right? So we have to build a model based on the algorithms. Then we will start tuning the model. Okay. There are in model building, we have supervised and unsupervised learning. Unsupervised learning where you will not have the output variables. In supervised, you will be having the output variables. We will look into that. Once the model building is done, we have to evaluate the model, whether the accuracy is perfect or not. Model evaluation plays an important role. Then the model evaluation is done. We have to deploy the model into the client mission. Model deployment is also part of data science. So you have to deploy the model. Once the deployment also done, we should do monitoring and maintenance. We should not leave our client like that, right? We have to do monitoring and maintenance of the data. So let us read the other things now. So we know that there are few applications of, applications which we have seen yesterday: speed up drug development and discovery, boost safety and risk management, machine learning in clinical research and development, more effectively target particular patient populations, improved understanding of the patient experience and behavior, boost the effectiveness of clinical studies, improved understanding of the effectiveness of sales and marketing. Now we will get into the unsupervised learning. Okay, what is unsupervised and what is supervised? What is the difference between the unsupervised and supervised? These are the important things which we need to understand. First, let us discuss about unsupervised learning. So what is called as unsupervised? So let us speak. There is some database. The data is directly coming from the database. Some videos, audios, text files, direct data, videos, audios, text. So this kind of data will not have any output. First of all, any output variables. When a data is having only the input variables, no output variables. When a data is having only the input variables, no output variables. Okay. When a data is having only the input variables, no output variables, then it is called as unsupervised data, because this unsupervised data, only input variable, I will put the data in my training set. What I will do, I will take the data first, then I will put in the machine learning model which I built. It will give me some rules and patterns. Make it clear, rules and patterns. It is not giving any mathematical calculations. It is giving some rules and patterns. I will collect this rules and patterns. And when a new data come in, I will apply the new data into my rules and pattern. I will get a prediction values. I will get the prediction values. The output will be predicted. This is the values we will get. This is the unsupervised data which really happened in the real world. Okay, this is about unsupervised. Now let us look into the supervised. If I say there is no output in a data, that is unsupervised. If a data that is having input as well the output, if the data that is having both the input as well the output, then it is called as supervised learning. Because what I will do here is I will split the data into training and test set. Let us say some 80% of the data into training, 20% of the data into testing, 80% of the training into training, and 20% of the data into some testing phase. Okay. If I keep this way, what will happen? So this is my historical data. I'm splitting the data into training set one part and validation here. So when we have validation, when we have high hyperparameters, we will be splitting the data into three splits. One is training, another one is validation, another one is testing. So let us say this is training, this is validation, this is testing. When you have high hyperparameters, large number of hyperparameters, so the training data set will have output and input. So I will train to the machine learning model I developed. I will run it and I will get a mathematical equation here. What I will do, I will put this mathematical equation to the validation data. And I will check whether the output is correct or not, predicting correct or not. Until it's predicted correct, I will change the validation. I will test it in the validation only. Then once I get the good model validation outcome, I will put in the new data to check whether my model is working good or not. The new data, already I have the output. So I will put the mathematical equation and I'll get the output and I will compare the output with the value. I will compare the output with the output values that I have already in the data. If the accuracy is good, then my model is good. If the accuracy is bad, then my model is bad. This is how the supervised learning will work. The splitting is like this: training, first training, build a model, training, build a model. Validation set we will use the validation to validate the data, then training set. Combine the training and validation data to run the model, which has been desired results based on a set of finalized model parameters. Then this validation is for hyperparameters tuning. I will tune my hyperparameters multiple times so that I will have a good data. Also ensure that model neither overfit nor underfit. My model should not be overfit or underfit. Okay, my model should not be overfit or underfit. What is overfitting, underfitting? I will tell you. Now I have done my analysis. I have done a model building. Now I have to evaluate the model. If this is for supervised, that is for only supervised modeling. If I have the output variable is categorical in nature, that is in textual format, I will use confusion matrix for the evaluation method. Let us see actual class and prediction class, predicted class. Already the prediction is done. Actual class. For a patient, the disease present or not. That is what I'm going to analyze. So the disease is truly present. Actually, the disease is present to the present. And the predicted value also say it is present. Then it is called as true positive. If the disease is absent and the algorithm says that it is false positive, then it is good model. But if there is a disease present to the patient, but it is showing there is no disease, then it is false negative. It is going to affect the patient because he's not going to take care of any medicines with him, right? No medicines will be given to him. So he will be having a problem. He will be having a problem. Right? Right. I hope it is clear for you now. Right? But here disease is absent, but it is showing true. This is fine because maybe it is not going to affect the patient. The point, it is not going to affect the patient. So which is obviously it is true. Right? So accuracy is equal to true positive. All the true values divided by the total number of values here will give you the accuracy. Errors, all the false value divided by total value will give you the errors. That is what given here. Then we have precision, sensitivity. Precision is true positive by total true positive values. True positive, predicted positive, that is probability of correctly identifying a random patient with disease or having or not. So initially we've done a model. Then I'm checking whether the model is good or not. If it is good, then there is no problem. If it is bad, it is a problem. evaluations for categorical data. Then sensitivity is also there. True positive by true positive plus false negative. Sensitivity. Specificity is also there. True negative rate. True negative by true negative plus false positive. Proportion of people with no disease being characterized not having this. Then false positive rate 1 minus specificity. False negative rate 1 minus sensitivity. F1. This F1 score is also called as harmonic mean. Precision multiplied by recall. Precision plus recall. F1 score should be 1 to 0 and defines a measure that balances the precision and recall. It is simple. If you have your y as continuous, that is a numerical values, then you have to take mean errors, mean absolute deviation, mean squared error, root mean squared error, and mean absolute percentage error. These are important. First, I will explain the mean error. Actual data is 100 and the forecast model says that first model says that 101. Error is 1. Actual data is 200, the error is 1. Fine, minus 1. Actual data is 300, but it says 301. That is some error is there. 400 and the error is this. There is some error, but when I accumulate it, it is showing me no error. But for this reason, statistician made square of the values. They made square of the values. Second model, they just squared it. So now, see, this is what the square here made. So the difference is 10. So 10 minus 10 minus 10. So if the square is there, you can say that 1, 1, 1, 1. The error is 4. There is some error. So after the square, right, it is doubling the unit. I don't want that. So in order to reveal the double, so they took the root. That is how standard deviation come into picture. So here see model 2 gives 10 minus 10, 10 minus 10. Here also 0 error. Right. So this is how root mean squared error, mean absolute error, all these things. Accuracy and error, if I added, it should be 100%. Accuracy plus error is equal to 1. Important criteria to be remembered. Accuracy plus error equal to 1. Then overfitting and underfitting. What is overfitting and underfitting? I'll explain. Okay. I'll read the diagram. Okay. Overfitting is variance. Variance. Underfitting is bias. What is variance and bias? Variance, overfitting speaks about training data. Underfitting becomes testing data. When my training accuracy is high and testing accuracy is less, when my, it is speaking about testing data, it speaks about training data. When my testing accuracy is high and training accuracy is less, that is called overfitting. When my training accuracy is high and testing accuracy is less, that is called underfitting. It's called as biased. You can see that in this data here clearly. This is my predicted line. This is the original value. This is what it is called as. This is underfitting because my original is this and it's this. Here it is overfitting. It will go all the errors and it's capture all the noise. This is the right fit model. This is for a regression model. This is for classifications. You can see that right fit will be like this. Okay. Sorry. So I hope that overfitting and underfitting is clear, right? So this is for today. We have discussed about a complete detail of CRISP-MLQ, how to a problem starts and how the problem ends we have discussed. Tomorrow we will discuss about exploratory data analysis, one good data set. We will discuss what EDA is done. Then we will also encounter all the things there. Please subscribe to our 360DigiTMG YouTube channel and watch the 75 domains which we have made in India's #1. We have made it, so no other have done it. So please make use of this opportunity from us. Do watch the video. Before that, please subscribe and click the bell icon for our channel. And if you are beginner level, then you can watch the Tam the Python by Bharani Kumar Depero, who is having an experience of 17 plus years. That is tremendous. He's having an unlimited knowledge. That is nice. So you people have to use that. So please look into our videos. Thank you very much for appreciate that. Have a great day, guys. Thank you. We'll meet tomorrow.